Hi, today we're going to talk about the special products of polynomials. Prior to this, we've talked about multiplying polynomials, and specifically we did a monomial, one term times a polynomial. And then also prior to this, we multiplied two binomials together. And that process was called the FOIL method. Well, today is a little bit of an extension of that. And we're going to try to develop and come up with some patterns for multiplying these special products. And these little patterns, they're kind of shortcuts if you want to think of it as that. They're meant to save us a little bit of time, a little bit of work, and hopefully maybe make it a little bit easier. But let's give it a shot here. So when I talk about the square of a sum, okay, I have a sum, two little terms being added together, and I'm going to square it. Well, I think most of you guys know, what does it mean to square something? Well, to square something means to multiply it by itself two times. Okay, so I'm going to multiply x plus 3 and x plus 3 two times. Okay? And this looks like we've seen before. What if I FOIL this? Watch what happens. Here I get x squared. Then I get 3x plus 3x. If I add them together, I get plus 6x. And when I do my last terms, I get plus 9. Okay? So I get x squared plus 6x plus 9. And I'm just going to briefly mention it here. I'm going to ask you to see if you notice any relationships between the numbers in the parentheses here and what I ended up here with at the end. Okay, and we'll come back and point out some differences here, some similarities in a minute. Okay, let's try this middle one here. Excuse me. Okay, well, x plus 5 squared means to write x plus 5 times x plus 5 two times. And let's try FOILing it. Here I get x squared, and for my middle terms I get a 5x and a 5x. Add them together, I get 10x. 5 and 5 gave me 10. And then the last number was 25. Okay. Again, are there any relationships between the first term here and the first term here? Look at the last term here and the last term here. And then the middle term, 5x. I'm sorry, 10x. Okay. I got one last one. Let's see if, and some of you might be getting it here. Let's try this one. X plus 10 squared. Well, that means x plus 10 times x plus 10. Okay, and if I FOIL, there's my first terms, x squared. My outer ones are a 10x. My inner ones are another positive 10x. 10 and 10, I get 20x if I combine those like terms. And then my last terms, 10 times 10 is 100. And are we seeing any relationships between the first number and the first number, the last number and the last number, and then the middle number? Okay, there actually is some relationships there, and I'm just going to point it out and cut to the chase here. Okay, the first number in my answer, now remember this is a quantity that's being squared. The first number here was the square of the first number, x squared. Okay, up here, x squared is x squared. Okay? The last number came from the square of the last number. 10 squared is 100. 5 squared is 25. So that's where those numbers came from. Okay, and a lot of times when people see this, that's just what they do. They do the properties of exponents. They just square the first one, square the second one. But they're missing the middle term. Hey, where did the 20 come from? Well, the 20 came from the two x's. Okay, the 10x and the 10x, and they were added together. Okay, well, here's where this middle term comes from. What we do is we multiply these two together, 10 times x, and then I double it. I times it by 2. Okay, and why do I times it by 2? Because there were two of them being added together right here. So 10 times x is 10x, and I times it by 2, I get 20x, and that's where the middle term came from. Okay, how about up here also? Okay, the middle term, if I multiply those two, that's 5x. But there's two of them. And 2 times 5 is my 10x, the middle term. Okay, it also let's see this top one. Okay, the first term came from the first number squared. The last term came from the 3 squared, which is 9. And the middle term, if I multiply them, I get 3x, but then I have to double it because there were two 3's. 3 times 2 is 6x. Okay, if I write this pattern, this little rule, kind of summarize it all together, it looks something like this. If I had a plus b and I squared it, okay, here's kind of the shortcut. It comes from the square of the first number, a squared, Okay? Then I multiply these two together, which is a times b, but then I have to double it. And another way of writing that is plus 2 times a times b. And then the square of the last number, b squared. Okay, so that's kind of the little pattern, the little shortcut. Now don't get me wrong, if you don't like it, if it doesn't really make sense to you a whole lot, okay, you can always do exactly what I did right here. You can always write it twice and FOIL it out. That's perfectly fine. But I'm going to ask maybe today that you try to use this little shortcut. Okay, let's try a couple here on the next page. I got 4 of them. Oops. This page is in your book. I forgot about this. This page is in your book, so you can look at it if you want to. Okay, but it kind of shows us the same thing. Okay, and here's a little example. They take the first number, and we're going to kind of skip this step, but they take the first number, they square it. They multiply the 2, which is 4x, and double it. That's how they get 8x. And they square the last number to get 16. Okay, so we're going to try it here. Here I got 4 of them. Let's try it without writing it twice. Okay, so this says I square the first number. The first number right here is x squared. Okay, then I sometimes do this. I multiply the 2 numbers, which is 6x, but then I times it by 2, because if I did FOIL it, there'd be 2 of them, and I get positive 12x. And then I square the last number, 36. Okay, so once you practice a little bit, it's not too bad. Okay, let's try this one. I square the first number, x squared. I multiply the 2, which is 9x, but then I'm going to times it by 2, because there's going to be 2 of them. 9 times 2 is 18x. And then I square the last number, which is 81. Now remember, 9 squared isn't 18. It's 9 times 9, 2 times, 81. Okay, and there's my answer right there. Okay, how about this bottom one down here? Okay, oh, can I square that? What if there's a number in front of the x? Do I also have to square the 2? Yes. 2 squared is 4, so I end up with 4x squared. I square the whole thing. Okay, I multiply the 2, that's 6x, 3 times 2. But then I double it because there's 2 of them, I'm going to get 12x. And then square the last number, which is 9. And there's my answer right there. Okay, same thing on this one. I'm going to square the first term, which I'm going to write down below here, 25x squared. If I multiply the 2 terms, that's 20x, 5 times 4, but then I'm going to double it to get 40x. And 4 squared is 16, and there's my answer. Okay, so that's how this is called the sum of the squares, or I'm sorry, the square of the sum. Okay, I add them together and I square it. Okay, but a nice little pattern, and again, if you want to use it, great. I'm going to encourage you to try and use it today. Excuse me. Okay, how about subtraction? Okay, a square of a difference. So pretty much the same thing, but instead of them being added in here, it's subtracted. Well, let's watch this. What if I write this twice, x minus 3 times x minus 3, and I FOIL it, kind of do it the long way. Okay, I'm going to get x squared, and I distribute here, I get a negative 3x. My other middle term, I get another negative 3x. Well, that's negative 6x. And I negative 3 times negative 3, when I multiply those, I get positive 9. Okay, and maybe some of you guys see it. Is there a similar relationship like this one with subtraction? X squared minus 6x plus 9. Let's try one more here with x minus 4. X minus 4 and x minus 4. If I FOIL, I get x squared. I'm going to get minus 4x. And when I do my other middle term, I get another minus 4x. Again, there's 2 of them. I get negative 8x when I subtract them. And then negative 4 times negative 4 is positive 16. Okay, turns out it's the exact same little pattern with this. The only thing is there's minus sign in there. Okay? And it's on this next page. Well, I'm going to leave it here for a second. Okay? What if I was to write this, and this might be worth writing down. What if I had a minus b squared? It's the same exact pattern. I'm going to square the first number, a squared. I'm going to multiply the 2. Now it's a negative ab. a times negative b is negative ab, and if I double it, I'm going to get minus 2ab. So it's the same thing, but it's going to be minus sign. Okay? And then when I square the last number, just like here, negative b squared is always going to be a positive b squared. Whenever we square something, it's always positive. Okay? So that's the second little shortcut that we're looking at today with subtraction. It's the exact same rule as the top one. Okay? This next slide, this is also in your book. If you wanted to try it, okay, take a look at it. It's there. I'm going to try it on these examples here. Let's see if we can do the same thing. Okay? See if we can use rule number 2 here. So if I square the first number, it's x squared. Now it's just going to be a minus sign. I multiply the two together as 5x, double it, I get 10x. And it's always plus the square of the last number, plus 25. There we go. Okay, we can do it here too. The first number squared is x squared. I multiply the two as 7x, and I'm going to times it by 2 to get 14x, and it's negative. And then 7 squared is 49. And once again, the last number is always a positive. Okay? Well, just like we saw when we did addition, can we have a number in front here? What if I square that first number? 6 squared is 36x squared. If I multiply that, that's negative 30. 6 times negative 5 is negative 30, but I got to times it by 2, which is negative 60x. And then I square the last number, positive 25. Okay? So again, once you get the hang of this, it's a little bit faster than writing it out and foiling it. Not that it's a race, but maybe save you a little bit of work. How about this guy? I square the first number. 4 squared is 16x squared. Not 8, but 16. If I multiply those two, that's negative 8x, but I got to double it. So it's another negative 16x. And when I square the last number, 2 squared is 4. Okay? And there we have it. So they're really the same thing, just a different sign right here in the middle for the middle term. Okay? All right, so there's 2 special ones. And there's one last one, a third one. The product of a sum and a difference. So we're going to kind of foil, but if you notice, 1 is plus and 1 is minus. It's the same numbers, but different signs. And let's see what happens when we foil here. Okay, I get x squared, then I get minus 6x and plus 6x, and at the very end I get minus 36. So if I foil it just like we've done in the past, let's look at these middle terms. They're like terms. What happens with a negative 6 and a positive 6? Yeah, they cancel out, they go away. And I'm just left with x squared minus 36. Huh. Okay. Notice any little patterns there. Pay attention to those middle terms as we do these next ones. How about this guy? If I foil, there's x squared. I get a plus 8x. And the next one is a minus 8x. And right now, yep, they're going to cancel out again. And then I end up with a negative 64. So it's just x squared minus 64. Okay, and again, you may be noticing some patterns between that, or some relationships between that and that and that and that. Okay, Okay, how about the last one here? I get x squared. I get a plus 2x. This one's a minus 2x. And a minus 4 when I foil. And those middle ones go away, yep, and I end up with x squared minus 4. So it's very similar to this. Okay, but if you notice the answer, there's only 2 terms. It doesn't have a middle one. The middle one canceled out, so this middle one here kind of goes away. Okay, and maybe some of you see the pattern, the relationship, but here it is. If I have a plus b times a minus b, okay, I have the same numbers, just different signs. The pattern is, the answer is the square of the first number, the square of the last number, and they're separated by subtraction. And if you look closely here, My answer was x squared. So it's x squared, square the first number, and then 6 squared is 36, and they're subtracted. X squared, and then 8 times 8 is 64. X squared minus 64. X squared minus 4. Okay, I have a couple examples of this. This is also in your book. Again, same thing as we've seen with the other two patterns. I have them right here on the side as well. Okay, but you can certainly look at it right there. Okay, we're almost done here. Okay, let's try this one without having to actually FOIL it out the long way, if you want to call it that. Okay, so the first term is x. I'm going to get x squared. The second number is 5. 5 squared is 25, and we subtract them. Okay, it's pretty slick. This one, x squared, 7 squared is 49. So really we're just multiplying the first two and the last two. Okay, for these bottom ones, can we have numbers in front as well? We sure can. And whether you think of it, this number squared, which is 9a squared, or maybe you just multiply the first ones. Okay, the last ones, 2 squared is 4. 9a squared minus 4. And once again, I saw a couple of mistakes on the homework. I keep emphasizing this. 3 squared is 9, not 6. Just be careful of that. Okay, this one, 5 squared is 25n squared. That's my first number squared. The last number is a 1. 1 squared is 1, and it's always subtraction. Okay, later on here in this chapter, we're going to start with this. We're going to go backwards. Okay, and we're going to pay attention to the subtraction sign in the middle, but it's always subtraction when we multiply these together. Okay, so just kind of 3 little shortcuts we're working on today. We have one last picture, or one last thing for us. It's this guy. Find the area of the shaded region. Okay, now I think we saw one like this on the last assignment. To find the area of that red region, kind of in words, what we're going to do, okay, is we want to find the area of the big square, and that would be the whole thing, the whole entire thing. But we don't want the white one, so we're going to subtract off the area of the white square. Okay, so if I just take away the white, that's going to leave us with the red, and that's what we want. Okay, well, both of these are squares, and the area of each one is going to be length times width. The area of that one's a length times a width, and then we're going to subtract them. Okay, let's start with the big one here. Okay, the length of the great big one is 2x plus 5, and the width of the big one is right here, 3x minus 1. Okay, and we're going to subtract from that the length and width of the white one. We're going to subtract x plus 1 and x plus 3. And notice how I put that in big brackets. Okay, we're going to put this together and we're going to subtract that whole big large quantity. Okay, I'll scooch it up so I have a little more room here. Okay, and actually I guess if I wanted to, I could do this. Okay, to kind of group them separately. Okay, let's FOIL. Okay, here I'm going to get 6x squared minus 2x. I do my inner ones as plus 15x minus 5. Okay, and if I simplify that a little bit, I get 6x squared. If I do my middle terms right here, negative 2 plus 15 is plus 13x minus 5. Now that's my area of the big one. I'm going to subtract off the area of this, the little one. Again, if I FOIL, I get x squared plus 3x plus 1x plus 3. And if I kind of keep all of that grouped together, and if I combine my like terms right in here, I have a 3x plus a 1x, I get 4x plus 3. Okay? And notice again how I kept each area in parentheses. Okay, and why is that important? Whoops, that's important because right here, okay, this subtraction sign, we're subtracting all of this. Okay, so that subtraction sign changes the sign on all of these things. Okay, and if I subtract my polynomials here, I get 6x squared minus 1x squared is 5x squared. Okay, then if I do my x's, 13 minus 4 is positive 9x. And then negative 5 minus 3 is negative 8. That would be my answer right here. Okay, that would be the area of that red square. Okay? So again, the big thing with this one is kind of write it out in words, is what we want to subtract to find the leftover parts. Group them together in big parentheses like I did right here, big brackets. And just keep those parts separate as you work your way down, combine your like terms, and you should have it. Okay? All right, very nice. Again, this was some special products of multiplying polynomials. 1, 2, 3 shortcuts you can use. All right, until next time, thanks for tuning in.